Hey guys, today we're going to continue solving limits, and we're going to do it more algebraically. So some of these problems are going to be from yesterday's assignment. If you were confused on them, here you go. Really crazy things with letters in there. And the easiest thing to do for these is, again, you're going to try to plug in your value to begin with, and if it doesn't work, then that's when you try to manipulate your equation. So if I plugged in h is 0 into this equation, I would see that I would get x plus 0 squared, which is x squared minus x squared all over 0, and that would give me an indeterminate form of 0 over 0. So I'm going to try to manipulate my equation in such a way that I can find the limit. So if I went ahead and I FOILed this out, or I used my box to FOIL this out, I would get that this was x squared plus 2 times x times h plus h squared, and then minus x squared all over h. Interesting thing happened here, and that's that my x squareds canceled out. And now if you notice, every single piece has an x in it, or an h in it in the top. So I could go ahead and I could factor out that h. And then if you notice, since this is multiplying, I am more than welcome to cancel out this h. So now if I'm looking as the limit as h goes to 0, I can plug in 0 right here, and 2x plus 0 is 2x. So my answer would just be 2x. So I can have letters in my answer, that's fine. If there are more than one variable in your equation, that's what's going to happen. So let's look at another one like that. Again, my first goal is to try to plug in the number that they give me to see if I could get a number out of it. So I would have 2 plus 0 cubed, which is 8, minus 8 over 0. This makes me sad. It's indeterminate. It's 0 over 0. So I would go ahead and I would multiply 2 plus h cubed out. And you could either use your binomial expansion, or you could just FOIL a bunch of times. But if you FOIL this out, you should get 8 plus 12h plus 6h squared plus h cubed minus 8 all over h. And so you're going to notice the same thing happened. My 8's canceled, and now every single thing in the top has an h in it. And so I can factor out my h. And then I'm able to cancel out the h in the top and the bottom, which then makes this something I could plug in 0 into. So I would get, this goes to 0, 0, and so my answer for this one would just be 12. So again, that's how you manipulate. You got to know how to factor or use your FOIL method. Now, something like this looks a little more scary. And again, if I tried to plug in this number from the start, I would have 0 over 0, and I would be very sad. So I'm going to go ahead and try to find a common denominator in the top so I can make one big, giant, ugly fraction. So my common denominator would be just these two things multiplied together, or 4x. So for this first one, I'm missing an x, and for the second thing, I'm missing a 4. So if I look at that, I would have x over 4x plus 4 over 4x all over 4 plus x. And now that I have a common denominator, I'm able to just add up straight across. Oh my god. Okay, and then I put over 4x all over 4 plus x. So if you remember, keep, change, flip, I'm going to go ahead and keep my first fraction, change my sign. It's not a division anymore, it's a times, and flip over my bottom number. And if you notice here, even though they're in a different order, x plus 4 and 4 plus x are the same thing. So these things cancel. Now I'm just left with 1 over 4x, and I can plug in negative 4 into that. So the limit as x goes to negative 4 for that one is 1 over 4 times negative 4, or 1 over negative 16. So remember your fraction rules and manipulating those crazy rational functions, and you'll be fine. The next thing that you're going to see is something like this. And what I really want to do with something like this is plug in and pray that it works, and it doesn't. 7 plus 2 is 3, or square root of 9 is 3, minus 3 all over 0 again, so I'm sad. I've got to manipulate. And what you're going to do here, if you have something crazy with square roots and stuff, is we need to multiply by the conjugate, which is something we did with imaginary numbers, because I want to get rid of this square root business. So I'm just going to multiply by the square root of x plus 2 plus 3, and whatever I do on the top I have to do on the bottom, And what this is going to do is it's going to cancel out the square root in the top, but it's also not going to leave me with the square root there, so I can hopefully do something with it. So it's just that a squared minus b squared business. So I'd be left with square root of x plus 2 times square root of x plus 2 is x plus 2. Negative 3 times positive 3 is negative 9. Remember, my middle thing's going to cancel out if you FOIL. And then I'm just going to leave this like this. I'm not going to try to FOIL it out right this moment, unless I am forced to do so in a moment. But if you notice, this top part is then x minus 7, which, hooray, will cancel out with this bottom one, and I'm just left with 1. Remember, it's not 0. There's still something up there. It's 1 over this thing. But I can plug in 7 into this. If I plug in 7, I get 1 over the square root of 7 plus 2 is 9, plus 3. So the square root of 9 is 3, so 1 over 6. So again, you need to multiply by the conjugate in order to get rid of the square root business, and that's how you can manipulate something that looks like that guy. The last type of function we're looking at is that piecewise, and so you are more than welcome to draw these piecewise functions out if you want to look at what the picture looks like. So if I was to graph this piecewise function, this is terrible, I should have put a graph in here. 1, 2, 3, 1, 2. So I know that my function, if x is not equal to 1, it's basically this line. It's 2x minus 2. So it's a linear function that has a y-intercept of negative 2 and a slope of positive 2, so up 2 over 1. Now remember, it can't equal right there, so I'm just going to put a gap in there, put an open circle, up 2 over 1. And then I would connect my dots with theoretically a straight line. And then if it is equal to 1, we know that my function's equal to 8. So there's just a random dot hanging out up there. So if I'm looking at this graph, I can evaluate the function at 1 because it does equal 1. So x equals 1 for the second part, so it would be 8. And I could evaluate different limits on here. If I tried to plug in 0 into this function, it's not equal to 1, so I'd plug it into the first thing. So I'd have 2 times 0 minus 2, or negative 2. And I could see that on my graph as well, because as I'm going to 0 from the right side, it equals to negative 2, and from the left side, it's equaling negative 2. Now the problem is at 1. So when you are calculating this, you want to know what is your graph approaching, your whole graph, not what it equals to, what it's approaching. So as I'm coming from the right side on this graph, it equals the y value is 0. And as I'm coming from the left side, it also equals 0. It's approaching 0. And so my limit there would be 0. It doesn't have to equal. These two do not have to equal. So you can draw your graph if you want to on a piecewise function. You also don't have to draw your graph. So when I'm looking at something like this, I want to know the limit as x goes to 1 of my whole function. And so you're looking at two pieces, the two sides where there's that end value of 1. And so when I look here, as x is approaching 1, sorry, I had to readjust, I want to know what it's going to equal from the left side and from the right side. And I always think about this as if it's a greater than, it's a right side, and if it's a less than, it's a left side. So less than, left side. So if it looks like a greater than, you're going to go ahead and use that one. So if I'm looking for my right side, I want to go to the greater than one, and I know 6 times 1 is 6. So that would be what my function is approaching from the right side. Left side, I'm going to go into my less than, and I would have 2 times 1 plus 4, which is also 6. And so if my function is approaching the same value from the left and the right side, I know that my limit is equal to that number. So that would be 6. Now if I did the same thing for negative 2, again, I have to look on both sides. So I have to look on my right side and my left side. I'm going to move this over here. So my right side is going to be the greater than. So if I plug in negative 2 into this function, that's what I'm looking at. So I have 2 times negative 2 plus 4. So negative 4 plus 4 is 0. Then if I look from my left side, that's the less than, and it's always going to be 2 for that one. So as it's approaching that, it's approaching two different values. It approaches 0 from the right side, 2 from the left side. There's a break or a jump in the graph, so my limit does not exist. And again, you can draw the picture if you need to, or just plug in values and make sure that they're equal to each other at that point. Otherwise, your limit does not exist. And that's all I've got for you today.